Hello and welcome to the recording of Managing Microservice Secrets on OpenShift. I've also put in a bonus of how to manage this with Jenkins Pipelines. Basically, this is a talk that I've already done at some meetups, and we thought that it would be good to record this, put it on YouTube, get it out there, let other people take a look at this that might not be able to attend those meetups. I'm hopeful that if you do enjoy this, give us some feedback. If you come across this and you think that there's something missing, please do let us know. You can tweet me at BobbyJason or get in touch with your UK Cloud account manager and just let us know. Let's get started. So what you're going to see, or what you're going to learn, I've basically made a list of what I'm going to go through. So basically what OpenShift is, I'm going to give a background of what OpenShift is and why you might be interested in it. As part of that, I'll be showing you how you can just deploy some code and let OpenShift do the rest. That's literally pointing your OpenShift to a GitHub URL and letting OpenShift deploy it. Now you might think, how does that work? I'll go into that. How you can quickly deploy it and build any ready-built Docker container, basically. If there's something in Docker Hub that you want to just deploy, you can say, hey, this is the Docker Hub URL, go and deploy it. If you've got your own Docker file and you want to build that Docker file, push it to OpenShift image repository instead of Docker Hub or key.io, whatever you use, you can use OpenShift version instead. I've also got some examples on building and deploying microservices. I'm also going to cover how to manage secrets. I'm also going to cover how you can set all that up with a YAML file instead of having to type the commands, which you'll probably see me doing. I'm also going to show you how you can put in deploy all that using Jenkins Pipelines. Hopefully that will work. Given it's a recording, I can probably cheat on that one anyway. So basically, what is OpenShift? OpenShift is it's an application development and hosting platform from Red Hat that automates the provisioning, management, scaling of applications so that you can focus on writing the code for your business startup or big idea. That's what I took off the Red Hat website. What does that actually mean? Basically, what it is, it's a platform as a service. Instead of you having to worry about deploying servers into your cloud platform, such as creating an instance, I want an M1 large or an M3 large, I want to create an Elastic Beanstalk, I want to create a server in this public subnet, I want to create a Bastion host and this private subnet, link them up. What? You start getting confused, or some people do anyway. And when you're starting to create all these services together, you need someone that can manage the infrastructure. Then you have to start automating it, and you have to start looking after your IAM roles and user groups, and start having to think about where your storage is attached and what your build process is. Are you going to set up some CI/CD that can hook into your cloud platform? And you start having to do things like Packer and Terraform, and you have to get a lot of DevOps skills involved, and it gets quite complicated very, very quickly. I know that because I'm a DevOps professional myself, and that's why I love OpenShift. It makes my job a lot easier. Basically, what it is it's built on top of Kubernetes. It's almost a distribution of Kubernetes on steroids. Basically, what it does, it allows you to deploy your Docker containers and orchestrate them with the power of Kubernetes, but with the facilitation of OpenShift on top of that, which covers an internal image repository, build configurations, deployment configurations. It's a fantastic source to image builder, which allows you to deploy just something from GitHub, deploy Docker Hub, Docker image straight away into OpenShift. It's also got things, it's really, really secure. It's had a lot of pen testing. Everyone says it's so secure and can't get into it. There's just lots of things that you can do. You can configure Kubernetes secrets through it, and it's really, really fast. That's in essence what OpenShift is. If you're watching this, you probably don't know what it is, so I've probably given a big enough explanation as to what it is. If you already know what it is, there was probably a better explanation than that, but why are you watching this? So let's crack on. This little image, thanks to MJ at Red Hat, I stole this from him, but it's a fantastic screenshot, basically showing the difference between OpenShift and basically Kubernetes do-it-yourself, which is basically showing that if you took Kubernetes to do everything that OpenShift does for you, you would have to do all the stuff in green yourself. OpenShift does everything. So kind of just, at this glance, it just shows you the difference between having to do everything yourself and what OpenShift does for you. So it is a really good image. But I think, rather than going to that, I think what I'm going to do now is get started into the crux of what you want to see. So I'll do that now. Okay, so what I'm going to cover next are the OpenShift components. This is not an exhaustive list, it's just a list of things I'm going to cover in this talk. The first part is the actual build, and that is what takes your Docker file, and it builds your Docker file, and it outputs the image to the image stream, which is effectively like the Docker Hub, or Artifactory or key.io or Amazon ECR, wherever your container registry is, that's where the build will be output to. And now you've got pods, which is essentially just a group of containers, and then you've got your services and applications, which is basically just the grouping of your pods, basically. You've also got deployment configurations and build configurations, so you can configure the build where it's going to output to, such as the image stream, and also the deployment configuration, which determines what the image, where the image should be deployed, which application and what service it belongs to, which also couples nicely in with routes, and routes are where you determine the actual endpoint URL and where that URL, which service that URL will point to. You can also use that for load balancing between multiple services and things like that. And lastly, I'm going to be covering secrets, which is obviously a way that you can store encrypted stuff without anyone knowing what it is, and hopefully I'll be able to show you a good example of that in a bit too. What I wanted to cover about images, which I kind of briefly mentioned at the beginning, is the fact that you can create an image from a directory source. You can literally just say, here's my directory with my Docker file, go ahead and create it. It uploads the Docker file, it'll build, and it'll output to the image stream. You can also do a source to image build, which is basically give it a GitHub URL, such as WordPress. It'll go, oh, this is a PHP application. I'm going to go and get a PHP Docker container and put the code onto this Docker container, and then deploy that. You can point it to a Node.js app, and it'll say, oh, this has got some Node code. I'm going to go and get a Node Docker container and put this code on there, and it will deploy it. So obviously it's very clever, and it does a lot of things for you, hence the whole idea of OpenShift being a platform as a service, rather than you have to worry about all these sorts of things. Makes life so much easier for developers. And lastly is from a Docker container itself. If you go to dockerhub.com or hub.docker.com and you see a MySQL Docker container on there available, you can literally just say create a new app from this Docker container. It'll go to Docker Hub, it'll download that Docker container, and it'll deploy that as an application. It is really awesome. Honestly, it's so cool. Best thing to do is to actually give you a demo of this running. First things first though, if you actually want to go and grab this, what you need to do is go to github.com and go to OpenShift Origin, I believe is the URL. Hopefully I've got that right. OpenShift Origin. You can go to releases, just go and get the source code, put the OC application in your user local bin path or wherever you store your applications, and you should be able to get up and running with that. Obviously I've already done that, so you can see if I type OC version, OC is in my path, and I can see that works, and you can see what version I'm running. Then what you do OC cluster up. I've got installed on my system the latest version of Docker, whatever that is. The date right now is Sunday the 1st of October, so you can take it from that. I've got the latest version of Docker, whatever that is. So whilst some people have obviously used this beta build on older versions, I can assure you that it works on the latest build from Docker. Basically what this is doing, this has been a number of Docker containers to host OpenShift. In an ordinary world, you would be using a deployed version of OpenShift, whether that's in your own infrastructure, or if you're obviously paying to have this from a company such as Red Hat or UK Cloud, funnily enough. This does take a bit of time to spin up, so I'll clip the video here, and I'll pick it back up now. So here we go. What we've got is a URL that we can go to access, so I can just refresh this here. Not that one, this one. There we go. And straight away we've got the console that you can log into. My username, so told me here, is developer, and the password can literally be anything. Just log in 1, 2, 3. There you go. And this is what it looks like. We've got a project. There's nothing here. Applications, deployments. I'll go through all this in a bit more detail in a sec. What I'm going to do is give you the WordPress demo. So what I need to do is head over to my file here. Adjust my screen so that you can actually see what I'm doing. I'll go to the code that is necessary. As you can see, I do quite a lot of different code around here. This is one I want. This one, yeah, right. What I'm going to show you is this. Resize that. Okay, so I'm going to do OC new project WordPress. OC new project WordPress. Let's go. And as you can see, I did that pretty quickly. If I just go in here, I don't have it there for your projects. It's appeared there straight away. WordPress. Again, just like my project, it's just empty, nothing in there. Now, I'm going to show you an example of pulling from a GitHub URL. All I'm doing is giving it WordPress, which is just the GitHub repository for WordPress. I'm giving it a name, WordPress, and saying strategy source. You don't have to say strategy source. There's only two options, source or Docker. It's just that if WordPress have a Docker file in their code for development reasons, it might think that I'm actually trying to deploy a Docker file. It might try and build a Docker file, and I don't want to do that. I actually just want it to do a source to image build. So I wanted to scan the repository, see that it's PHP, pull in a PHP Docker container, and deploy the code. So what I'm going to do, I'm going to put that in here. And let's just wait for that. Okay, so we can see what that's done. We've now got a new app. It's found image, OpenShift PHP, tag PHP 7, and it's determined that obviously it matches the PHP guidelines that OpenShift uses for its source to image, and it's created an image stream, it's created a build config, it's created a deployment config, it's created a service. It's basically done all this itself for us. And as you can see, we've got a WordPress deployment. It's running a build right now. So what that build is taking a PHP Docker container and applying the code basically. It's got CentOS PHP 7, CentOS 7, and it's got this code. And we can have a look at the logs to see what that's doing. Push, it's literally just finished. So all it did was literally take that, basically cloned the repository, applied it onto the Docker container running PHP 7, and then pushed it to my image repository, which I've got running here. So straight away, it's created a PHP application running one pod. Awesome. What we actually now want to do is access this application, but we need a root to be able to access that. So what we can do, we can just go OC get root, and you'll see we don't have any roots at all. So what we need to do is OC expose service WordPress, root WordPress exposed. OC get root. Now we've got a URL that we can access. Obviously that's using the CLI. If I come into the GUI itself, you can see we've also got URL there. I could have pressed create root within the GUI, but it's just easier to do the CLI. So if I press this, we've got access to WordPress straight away. Obviously the next step is to enter our database details. We don't yet have a database, so what we need to do is deploy a database, which I'm going to do by the other method of deploying a MySQL container. I'm not specifying a GitHub URL here. I'm specifying just a Docker container. It won't find it, and it's going to go and pull it from one of its own registries. In this case, it'll probably go to Docker Hub. I'm also specifying the environment variables, user, password, and database. So I'm going to say OC new app, and set that going. Really, really quick. That was as quick. I've not edited the video. That really was quick. Rolling deployment is in progress. One pod about to deploy. So we can do view events, see what's happening. Pulling that image. If I just look at the builds, WordPress. Of course, this isn't actually going to do a build because this is literally just deploying the Docker container that was in Docker Hub. So actually this is kind of the point of showing this one. This is not having to take a Docker file and build. This is literally just taking the image that someone else has already built. So literally what it's doing is taking a Docker container and deploying it. Really, really simple. Okay, so as you can see, that's now up and running. MySQL 5.7, running on CentOS 7, and we don't need to expose this as a service. If we wanted to, perhaps if you're using SQL Pro on your Mac and you wanted to access this, you would need to expose the root so you can access it on port 3306, but because this is just running within Kubernetes, WordPress can just reference the MySQL hostname, so it's basically, it's got service discovery built in. You don't need to worry about what IP it's running on or whatever. Obviously, if you did want to know, you can come in here and you can see what pod it's running on. Deployment 1, if we go into deployment 1, you can see that it's running one pod. This is the name of the pod it's running, 1 out of 1. You can see how old it is. You can basically just see that it's running. It's got an IP address. You can even go to a terminal if you like, and you can see that this is the terminal for the MySQL place. Anyway, let me come out of that and have a look at our WordPress installation. So the database name is WordPress. There we go, and the username I set to WordPress, and the password I believe I set to secret123. Let me just check. Secure123, not secret123. There we go. Database host, it's not localhost, it's just MySQL, because that's what I called it. And submit. Alright, run the installation. Awesome, awesome, awesome. Yes, yes, awesome. I've done this before, you can tell. Right, install. And obviously, anyone that's installed WordPress before will know how relatively easy it is to install WordPress anyway. I'm not claiming that I've done something super amazing, but the fact that I've not had to worry about any servers, any security groups, any network, any public subnet, I've just not had to do anything. All I've done is said, look, this is the GitHub URL for WordPress, this is the Docker Hub URL for MySQL, deploy it please, boom, and it worked. It is so simple. So obviously, straight away, we've got a very simple website up and running. Obviously, I can just go there you go. WordPress up and running in literally a matter of minutes. Admittedly, if I didn't have me talking over it all the time and trying to explain everything, you could probably do that in literally about 2 or 3 minutes, which is superb. So that's just as an example of using the source to image builder, and obviously direct from Docker Hub as well. So now that I've covered that, let's see what else we've got to cover. Next on my agenda is a microservice app. So we're obviously getting a bit more complicated. What I've actually created, I say I've created it, I'll be honest. This is part of an example which we did with Red Hat, and I've expanded on this to show you guys how you can deploy this application using OpenShift. But essentially what it is 2 services. One of them is an API that connects to XKCD to pull back a random funny XKCD image. If you don't know what XKCD is, just Google it and you'll see. It's basically just a funny geek comic web strip thing. Then we've got a front end which uses the API to display that random image. So what we've actually got, we've got some Go code which we need to build, essentially just using the Go build tool. That will build the binary file which we then want to put into our container. So we get a Docker file, and we'll say copy this file onto our container and expose it on port 8080, build it and push it to our image stream or Docker Hub or ECR or wherever you wanted to put it. And then our next step is to deploy the application. So what I'm going to do now is show you a demo of doing that. So I'll do that now. What I shall quickly do is just give you a quick show of the application itself. So this is the application for the API. It's very simple. If you just look at the handlers, it's basically just going to pull in an image random from info JSON to show a random XKCD image. And that's basically what it's going to do. It's obviously ultimately quite a lot of code for what it does. But what we've also got is the front end, which is just the website. It's a very, very simple website. And again, the main, it's going to consume the API on API v1 image, and it's going to get the actual URL from an environment variable that we'll pass in when we create the application. So let's go ahead and show how you can do this. I've got a nice handy make file here, which I can use to get started pretty quickly. So what I'm going to do, I'm going to create a new build for the front end. And what is a new build? Before I do it, I'll show you builds. Right, this is in the WordPress project. So actually, I'm not going to use the WordPress project. I'm going to do OC new project. I wish I could type. CI. I'll call it CI because I've got some cool scripts after that I'm going to show you, which requires the project name to be CI. So if I come back to your projects, CI, right, builds, images, builds. There's nothing here. What I'm going to do is create an empty shell, literally an empty shell. New build, FE. That means front end, by the way. It's created an image stream and it's created a build config. So if I come in here, you can see I've got FE. There's nothing really here, to be honest, but it's got some configuration. It created a build config. It knows that when I built my build, when I've told it what to build, it's going to output to an image stream called FE latest, which would go in the images section. So what I want to do now is start the build, and literally all I'm going to do is say OC start build front end from file, and I'm going to give it the directory. I'm going to give it this directory here. All it'll do is upload this entire content, the Docker file, the image, the index, and the main.go, and also the built binary file FE, because I've already run go build. I've just done that for brevity, but obviously go build, you would press go build as well. I'm going to show you this all looped together with a Jenkins pipeline to show how this would work, but essentially all I've done is run go build and output to API, go build and output to front end. So I've already got my output application there running. So all I need to do is show you the Docker file, and the Docker file for the front end is from Golang. So what it's going to do is go to Docker Hub, pull the Golang Docker container. It's going to create a directory and copy the front end application into our deployment folder, and copy the image and index files, and then expose this service on port 8080. So literally all I need to do is type that command, OC start build FE. OC start build FE, and if I come under here, you'll see that a build will have been kicked off. Pending, running. If I look at the logs for it, you'll see it's just running through just exactly what a Docker file would do. So it's going through all those steps, what I just went through from Golang, make directory deployment, copy the image, etc. It's basically just run through that. Once it's finished running the Docker file, it's going to push it to my image stream, which I can come here, and it's got a tag, just like you would expect on Docker Hub or ECR or key.io, whatever your image repository is. This is exactly the same, but it's OpenShift's version. And now I want to do exactly the same, but for the API. So if I go and look at the API, which I actually need to create a new build API first. Go see new build API. Again, that's created a little shell API with no builds. There's nothing there. And if I then say start build, and the start build will upload this API directory, which has got this Docker file, which again pulls from Golang. It copies the API Go application into the bin API, entry point bin API, and exposes that on port 8080. The fact that they're both running on the same port is literally not an issue for OpenShift and Kubernetes, because they're in separate services. You'll see. So right, what I'm going to do is OC start build API. Come into here and say builds. There you go. It's pending. Number 1. Output image. When it's finished, so if I look at logs, I can see that this is in progress. Loading log. There we go. Pushing image. Push successful. So if I come and build images, I can tag that if I want. I've even written it down here to show you, funnily enough. I can say OC tag API latest with whatever version. So I can see OC tag API with 1 point like that if I wanted. And if I just come here, you'll see that it's got a tag of 1.0. You can obviously do that with whichever things you want. You can put whatever tags as you would, 1.1, 1.2. So now we've got our, essentially we've got our built Docker images. We now want to deploy these as containers, which we would do by the next steps. What we need to do is actually create an application. So we're going to say OC new. We're going to create the API first. We're going to say OC new app, call it API, and we're going to say pull it from an image stream API, which is our API image stream that we've already got, and just pass in some environment variables. So if we just take that, OC new app, I'm not pressed enter yet, but basically what it's going to do, it's going to come and create a deployment config here, and it will basically build us our application. So I just run that. Bush, deployment config, and a service. So if I just come back to here, you can see deployments. We've got API, and it's running, created in the last few seconds, and it's also created a service. API. If I look at this service, you can see here basically this service is just showing that it's a service running on port 8080, and it's mapped it to the 8080 in the container, and that's running on this pod. And you can see it's receiving traffic. Perfect. It's ready to receive traffic, but it won't be able to externally because we've not set up a route. So if we want to access our API, you can see this is running on one pod. This is running, awesome. We could press create route, or I could come here and I could say OC expose service API. OC get route. I've got URL, or I can come here and we've got on here. Go to that. Now, we've set up a specific path for our API to return our image, which we would have seen when we looked at main.go in the front end, which was API v1 image. So if I take that and put that up here, right. So what this app is now doing is talking to xkcd and pulling back an image and returning it to us. So what I can do, refresh, it should pull back a different one. Yes, it does. So every time I visit our API, it's pulling back a different image, which is exactly what we want. We know that our API now is working perfectly. So what we want to do, let's close that and deploy our front end. So if we come here and say OC new app front end, image stream FE, and an important environment variable here is we're passing in the URL to our API service. Now this is due to the design of this sample application. In most microservices that you might create, this service would look up on the API DNS name, and obviously it would use service discovery to determine what the URL was, or what the IP address was of that container. But because we're literally embedding the URL into our web page to pull back an image, we do need to pass it the full URL. And we've exposed the service on port 8080, and we've got the route set up, and we've verified that our application is working because we just went to that URL and viewed the images. So what I'm going to do is come here, OC new app, and we should now have a front end. So if I come here, close that, we've got a front end, and if your rolling deployment is running, it's basically all it's doing. If I just pull that, you can see what it's doing. It's using the build that we created 6 minutes ago. It knows to deploy the latest build, because when I just typed that command, I said use the image stream FE. Perfect. So if I come back to here, you should see that it's already deployed now, but we don't have a URL. Again, I could do create route, but I'm not going to. I'm just going to say OC expose service FE, and OC get route shows up there. So if I just click that, we should now see our UK Cloud image gallery. And random is the place where it calls our API. Image is going to load. Yes, it did. Awesome. If I refresh this page, every time I refresh, it's pulling back a random image from xkcd. So in essence, basically what we've done, we've shown you how to use source to image builds in our lovely WordPress demo. And I've also shown you how to take an image from Docker Hub and deploy that for our MySQL server. And then I've shown you how you can build a Go microservice, or 2 of them, and configure them by building up the individual build configs and starting the builds and uploading those files from a specific directory, and then creating an app which uses that image stream. So I hope you enjoyed that. The next step is for me to cover secrets, which I'll just begin by showing you that the current API password is default. So I'll move on to the next bit now. Okay, so we've got our application. We established that we had this up and running with a default password of default. That's basically just because I've not set a password. What about if you've got a service that needs to talk to each other and it needs to use a password, but someone hacks your system and you need to change your password? If you've got hundreds of containers running, how are you going to efficiently change that password? Do you currently have that process in place to basically change your passwords easily? Chances are you don't. Not many people do. I mean, how many people actually have a rolling password policy on their applications? Sure, people might have to change their password every 30 days on their email. What about your applications? Are they all talking to each other with the same password that they had 2 years ago? Quite possibly. Most applications I come across, that is the case. One of the amazing features about Kubernetes, again, building on the work of all the open source work from Google, and obviously pushed back into OpenShift as well, is the ability to manage all that. So what I've got an example of how you can do that. So if we go back to our file, I've got here secrets. So it just so happens I've got an app that I've created which generates a random password. You can use whatever tool you want. But basically all I'm going to do is output password to password.txt. I don't know what that is. I'm going to show what it is because otherwise this example would be a bit pointless. But in the real world, you wouldn't be showing people what the password is. I've just got a brand new random password, but that could be automated. If you'd got some system which was automatically generating a password, it could pipe a file into a text file pretty easily. So there you go, that's what the password is. So what do we want to do now? We want to create a new secret. So OC new secret is the command. OC secret new API password. I'm calling it API password, and I'm saying the password comes from that text file. Before actually running that, I'll show you how you would do that in here. It's under resources, secrets. You can see there are already some secrets which are in here, part of all the Kubernetes cluster for it to talk to each other. But I don't actually have any. I could come in here and create secret and type it in and type in blah, but I don't want to do that. But that's how you would do it if you wanted to. So I'm going to say this new password I've created. What I want to do is OC new secret and load it from password.txt. Password created. So now I can come into here and I can say resources, secrets, and I've got it there. And there we go, created a few seconds ago. And it's all full of asterisks, I can't see what it is, unless I say reveal, and I can only say reveal because I'm logged in as developer. I'm logged in as a user, which is entitled to see that username, or that password. Obviously, that is currently not it's not encrypted per se, but obviously it is hidden away, and no one would be able to see it if they didn't have access. So how do we put that in our application? There is another command that we can just see. If you didn't use the GUI, you could just say describe, and it just shows you that it's a password that contains 21 bytes. That's about it, really. But what we want to do, we want to put that password in our front end deployment config, because our front end would need to know how to communicate to the API if the API needed a password. It just so happens our API isn't secured, but just supposing if we did want to pass a password to our API so we could call the API, then we'd need a password. Obviously, you wouldn't expose your password on the front end either, but that's by the by. The whole point is I'm just showing you how this works. So if I come to applications deployments and look at the front end, I can see here from the configuration, environment variables, I don't have API underscore password, so I want to put an API password in here. So what I'm going to do is execute this command. So what's this command doing? It's saying OCenv, create an environment variable in deployment config front end, prefix this with API underscore, and put it from the secret API password, which is already in our stored area here. It's created a secret API password. So I just do that. Deployment config updated. So if I come in here and look at the deployments for front end, it's actually created another deployment already. The reason for that is because this deployment config is built to trigger on any change to its config. So it realized I'd updated an environment variable, so API password, and it decided to release a new version for me. So it deployed in our application. You can see that the front end is now on version 2 because it saw that I updated the password. So if I come in here, you can actually see because of a config change. Updated a few seconds ago, and as you just saw on the deployment config itself, we've got an API password, and it's set. You can't see what it is. It's just referenced to the key in API password in here. Obviously, I can reveal it there if I wanted to. So if I go to my front end and refresh, we've got the password there already, literally, and it's been deployed. It's so quick. It's amazing. That's great if you want to set a password. Updating the password is slightly different. What you actually have to do is delete the password from the resources section. So if I just delete the password and come into here, we'll see that it's no longer here. That doesn't mean that it's not in my application now. My application already stores a copy of the password on the container, so it already knows what it is. So the next step is to create a new password. So if I just create a new password here, I'm not going to see what it is. I'm just going to deploy. I'm going to create a new password, sorry. So now, if I come here, I shall see secrets. I've got a new password, and I'm not going to reveal it. I'm just going to deploy. What actually happens here is we've not actually updated the deployment config. So even though I've added a password, I never did this command where I passed where I told it to update the environment variable, because that's already the same. That wouldn't change. If I executed that again, it already knows it's got a password from there, so it wouldn't trigger any release. I don't need to make that link again. It's already got this link. All I've done is change the actual password that's in there. So I need to kick off a rollout of it manually this time, rather than it firing off a trigger. We'll see rollout latest, deployment config rolled out. So if I refresh this, let's see if it's got the same password or a different one. Still got the same one, I imagine. It's just not deployed yet. That's what I was hoping. There you go. It's deployed. Got a new password now. Awesome. If I come here in a few seconds, number 3, deployed with a brand new password. And one thing which I've not shown is that you can actually come into these containers and I can say terminal. Basically, you've got shell access to your machine. Basically, host name. You can see that's just the pod name. You can see FE3 because it's a third deployment. So you've got access and you can inspect this container if you want. You're very locked down. You can't do a great deal in here, to be fair. You can connect to MySQL on the other host if you had the correct libraries installed on here, but we don't. But anyway, that's an insight as to how you can deploy secrets on OpenShift. So what we'll be covering next is how to use some YAML, and we'll cover how to deploy Jenkins and Jenkins Pipelines. Okay, so the next bit that I wanted to cover was actually how to use a YAML file to create your environment. Because type in all those commands that you've just been watching, obviously that's not very manual. No one really wants to be type in OC new build, OC start build. That's a laborious process. So what we can do, we can create a YAML file, and basically everything that you create can be defined in a YAML set. Obviously this is a build config for a pipeline. So what I'm actually going to do, I'm not going to go and create all that stuff I've just created via a YAML file. I'm going to create something new, and rather than use the command line to say OC new build, etc., I'm going to use a YAML file, and I'm going to create a pipeline for our front end, so that when I commit some code and I want to deploy a new version of my code, I've got a pipeline which will go through and it'll build the Go application. It'll build it and build a Docker image and put it in the image stream, and then it will update the application. So it's kind of just an example of how you can integrate with Jenkins, basically, because OpenShift has got a Jenkins plugin, so it seemed like a relatively cool thing to show. But whilst I'm just on the YAML file aspect of things, everything that you create in here, so for example my API, if I go into the API deployment, I can go to Actions, Edit YAML, and I can see what the YAML is for this deployment config. Obviously, some of this is got some specific things in it which you could probably delete if you wanted to store this information in a YAML file. You could copy and paste it, put it in a YAML file. There's the other way, which actually when you're doing something, you can say OC new app, but instead of actually creating that app, if I just said test, you can say -o JSON, and it'll show you the JSON to create that new app. That's actually going off to try and find a I should use MySQL instead, because that's actually a container that it knows. So it's basically, it's going off and it's saying, look, this is the JSON for creating an app called MySQL, and it's going to pull it from the MySQL repository, image repository. Obviously, you can do YAML, which is what I'm going to be using. So you can use JSON or YAML, and obviously then you would copy and paste that into a file, and I'll show you how to use that file now. So for our pipeline stuff, I've got a little file here. I've already got a CI project, but before I actually kick off creating my pipelines, I need a Jenkins server. Now, built into OpenShift is a Jenkins ephemeral container that you can use. You can say OC new Jenkins ephemeral. If I just executed this, it would work. It would spin up a Jenkins server. It's going to pull one from its image store, Jenkins ephemeral, and obviously you can do Jenkins persistent as well. But I need Jenkins with the ability to build Go. Now, to build Go, what I need to take the standard Jenkins build and install the Go binaries on it. So actually what I've done here, I've got a Docker file here, where I take the OpenShift Jenkins build, copy plugins.txt so that I can have the Blue Ocean nice GUI in Jenkins. I just install Go, basically, and copy the plugins over. And set some permissions. That's about it, really. But the downside to that is that I do have to create this Jenkins with the OC new build, which kind of goes against what I just said about creating a YAML file, but that's just because I didn't put everything in the YAML file. You can obviously define a new build, and I could put all this in a YAML file. What this YAML file is doing is only the pipeline itself, not setting up the Jenkins slave, but you can do that. So I'm going to do that. I'm going to say OC new build, Jenkins Go. Again, quite similar to earlier on in this video. All that's doing is creating an empty shell. There's nothing in there at all. It's just Jenkins build, nothing there. Literally, I've not told it what to do or anything. So I'm now going to say start build, and I'm going to say from file Jenkins slave Go, which is this Jenkins slave Go. It's going to upload that Docker file and execute everything in there. So if I do that now, we'll see start build. Hopefully be fairly quick. There we go. That was pretty quick indeed. Awesome. So if I come out here and check that build, what that's done is created an output to Jenkins Blue Ocean Go latest. If I come to images, I've got a Docker image there ready to use. So now what I need to do is come here and say deploy Jenkins ephemeral from that image stream. Come here, OC new app. So what it's going to do, it's going to create a new app based on that image stream that I just created, which has got Go built into it. There we go. And now that's creating. Okay. So as you can see, we've now got a application that's ready to access, and we can access it via this URL. I'll just come here, going to log in using our Red Hat OpenShift login. Obviously this is, like I said, this has got a plugin with Jenkins. Because I use the name Jenkins ephemeral or Jenkins persistent, it basically has got some behind the scenes magic that happens. So I need to log in with developer login. If I come in, I'm going to say yes, authorize, and then I'm logged into the generic Jenkins style land. I can also say open Blue Ocean, which gives us the nice fancy GUI for Jenkins too, and obviously you can see stuff around in here if you want. Right now though, what we want to do is actually build our pipeline that we asked for, or create our pipeline, sorry. And what I'm going to do to build this file, to tell OpenShift to execute this file, is run OC create -f and give it a file. So I'm going to say OC create -f and give it the OpenShift pipeline. What that will actually do before I execute it, it's going to come and build something in pipelines. Currently I don't have anything. I could do create sample pipeline, I could go through and I can create all this stuff, but again, I don't want to do it like that. But if you wanted to do it manually, you can do. So I'll just hang there and execute that command. Bush, create a front end service pipeline and an API service pipeline. Now if I come here, what we've got are two pipelines that have not been started. what it's actually done is what I specified in my pipeline.yaml file. I specified the URL for this example application that I'm in. Obviously, that is the URL. If anyone wants to see all these demos, all this code is in github.com/go example app. And I specified the location of the Jenkins file for the front end and the Jenkins file for the API. Now, Jenkins file is a Jenkins 2 style way of defining your build pipelines. So obviously in the front end, I've got a Jenkins file for the unit tests. I've got one for building the binary, and it's basically using my make file that I was using at the earlier part of my examples. And we've got a build image, start build, and also a stage to deploy. Now, I'll cover this deploy bit in a sec. We don't actually need this because we've got build triggers. So actually when I do this build image, it's going to deploy anyway. I should probably show you how to disable that trigger, just because of the way we've created it. We've actually, when you're creating it using your YAML files, you would tell it not to create that trigger if you're going to be using a pipeline. So in this example, when I show you what's actually going to happen, is it's going to run through, it's going to build the binary, it's going to build the image. The current deployment will see, oh, you've just created a new build, I'm going to deploy, and then we're going to deploy over the top of that. So it's going to cancel one and start building the other. So it's not ideal, but I'll show you how to correct that anyway. So basically, as you go through this, what I shall show you is I'm going to say start pipeline. It knows to look for that Jenkins file. So I'm going to say start the front end build. Now, what happens is this is going to get picked up by this server here. This is very kindly going to pick that build up. So if I just go to pipelines, I can say view log. And view log actually takes us into Jenkins. That takes us to the old interface, nice. But basically, you can basically see the console output just as you would if you're familiar with that. If I say open in Blue Ocean, which thankfully the plugin puts everywhere, you can see progress of it in here anyway. API unit test is running, and the console output there. So you can view it in either version. I'm just going to come back here. I can see that it's now running the API unit tests. Okay, so as you can see, the API unit tests have passed, and now it's building the Go binary file. Typo, that should be FE unit tests. And it's now building. Obviously, it's just taken a while. Don't forget that my example is actually running on my Mac rather than in a real world deployment of OpenShift. But what you can see is at the front end, you can see that it's currently deployment 3, but it's got a pipeline. It shows that there's a pipeline building, and it also shows the build running. And now it can see there's a rolling deployment pending, number 4, because it's triggered. It triggered it. It knew that there was a new image. So what's happened now is, oh, I've got a new image. I'm going to deploy to number 4. But now it started the deploy stage of the pipeline, and it's cancelled the rolling deployment number 4, which had triggered automatically, and now it's deploying number 5. So obviously that's the bit that I was telling you about earlier. The way there, you basically just need to disable the trigger on the image change. But basically, if I just go back to my pipelines, you can see obviously resolution means that that's dropped onto 2 different lines, but unit tests, build, deploy, and that should build shortly, and we'll see that we've got a successful deployment. Basically, there we go. Build number 1 complete. And obviously, we'll do the same for the API service pipeline as well. To complete that, but I'll leave that off for brevity, because I think what I've done now is I've shown you probably about as much as would be useful. If I went into too much more details now, I think I would start overloading you with information. I believe what you've got now is enough information to start using OpenShift, see the power, how awesome it is. It really is an amazing tool that you can use. The fact that you can hook it up with build pipelines. I mean, obviously right now, I don't know, this video might have entered into the 50-minute region, but that's just because of me talking all the time. If you literally just take this code, which again, just for reference, you can get from github.com/go example app. You can take all this code and you can have a crack at it yourself. You could probably set up these pipelines within 10-15 minutes and start deploying this application really, really quickly. Honestly, it really is that easy. There's so many things you can do with it. I've got a lot of examples as well of how you can set up microservices with messaging if you use RabbitMQ, things like that. You can set up clusters. Obviously, there's much more detail I could go in with configuring your routes for load balancing reasons, because when you go to create route, you can say alternate services, split traffic across multiple services, so you can easily do blue-green deployments. The power within OpenShift is literally awesome, and I thoroughly recommend that you check it out. But for now, I'd say any questions, but this is a recording, so I doubt I'd be able to hear you. So thanks for watching, and if you've got any questions, feel free to tweet me at BobbyJason or tweet at UK Cloud. Thank you very much for watching.